Unsung Heroes of the Cloud, Episode 8. Today, Nils and Mike are here with Mayuri Gupta, who's going to be discussing Arc-enabled open service mesh. A lot of excitement about that, and we'll just hand it over to all you right now.
Cool. Hey, Mike. Hey, Mayuri. How are you doing?
Hey, Nils.
How are you?
How's life?
Life is fantastic, Mike. As I told you in the pre-show, the climate here in San Jose has been particularly nice. It's like a comfortable 25 Celsius, 80 degrees Fahrenheit, and no heat wave like the rest of the West Coast. I am perfectly comfortable. How about you?
So I'm gonna say you're not homesick then, because it's here fine Belgian weather. So like
so you have, rain.
Yeah, rain and then dark weather, and yeah, it's like depressing. A lot of fun, as always. That's Belgium, I guess. So I see we have a nice guest there. Hi, Mayuri. Where are you from?
Well, I'm actually from India, but currently I'm in Austin. Yeah,
In Austin. Austin, that's Texas, right?
that's Texas.
Yeah. Sorry, my American history, geography. I mean, of course, just all
That's
jokes
fine.
aside.
Then you and I are on the same page.
No. It's just always fun to see where people are from. So, what are you up to next to your daily huddle with what you're gonna present about?
So I'm going to talk about this product that I've been working on for the last 1 year. It's called Azure Arc-enabled open service mesh. This is one of the things that you can do when you have an Arc-connected Kubernetes cluster. So, Azure Arc is the offering, the platform that basically enables any on-premises or off Azure cluster to connect to Azure Arc. And once you're there, then this open service mesh, which is in fact one of the open source service meshes out there, how we deploy it and what all we do with it is something I'm going to talk about.
Oh, cool. So yeah, Arc, it's a hot topic today, right? Everything hybrid. It's we are actually feeding it. Force feeding it to everybody. But it's really a nice solution that we build up. Especially with all the announcements that we did for app services that we're running and all these things on the side. So yeah, I'm really looking forward to your unsung hero, because that's something I actually haven't heard about it, of the Arc-enabled open service mesh. So that seems very interesting to me.
It's actually very new. Good that you pointed that out. So we released the public preview of this offering in build. So that was in May this year. So it's relatively very new. People are just starting to explore it. What it really helps you with is that so you have this open service mesh, which is a CNCF contributed project, and then you deploy that. You can otherwise, even if outside of Microsoft, you can still go ahead and deploy this open service mesh on your cluster, right? But what we offer is the managing capability of it, the management capability of it, so that when you face any issues with the implementation, the controller pods, or the way the service mesh is functioning, you do have an entity, somebody to reach out to. In this case, it will be Microsoft. So, when you deploy it, we give you this life cycle management of the control plane. So we kind of do auto upgrades for you. It's not available now, but by the GA timeframe, we'll enable the auto upgrades for you, so that whenever there is a new version, we'll automatically upgrade, as long as it's not a major, overhaul, like a breaking change or so. We also kind of reconcile for any unintended changes made by the customer, so that they know, if at all, some team in the some team made some unintended change, it kind of gets reconciled. So we know that it is always in the right state where it needs to be. So those are the starting points. And yeah, go ahead.
Yeah, one question I had is, you mentioned Kubernetes there earlier. Is Arc-enabled service mesh something Kubernetes specific, or is that also coming to Azure Arc for servers potentially in the future?
That's a good question. It will. In fact, a lot of our customers have started asking about it, and that's going to be part of our multi-cluster story. Right now, it's scoped to a Kubernetes cluster, which is connected to Azure Arc. But we are currently running a POC for multi-cluster, where you would be able to connect at least go outside the scope of a single cluster and connect multiple clusters together. Something we are trying to share with customers in a private preview kind of a format. It'll be there like in a 6 months time frame, maybe a bit sooner. But first of all, the goal would be to try cluster to cluster communication over this mutual TLS sort of secure channel, and then of course expand to virtual machines. And yes, I think Arc enabled servers would be probably the first thing we'll start off with.
Okay. That is cool. And I don't know if you know, but I'm going to ask the question anyway. We now have Arc-enabled open service mesh. Is the same available for just regular Azure Kubernetes as well?
You AKS, right? Yes. So if you do deploy an AKS cluster, you can deploy this open service mesh as an add-on there. It's called an add-on there. Over here, we have a different name for it. You can also call it an open service mesh extension, but the same offering is available for both.
Okay.
Yeah.
That's cool. I mean, we're of course we had a little bit of a bias there because we had Phil on the show already, and it was like really passionate about it, and but we do love it. I mean, you need a good mesh, and open service mesh offers a lot of flexibility and a lot of opportunity to do better development of everything of your solution building. So, but it's cool to see that it also is coming to servers, because that will probably also enable new scenarios for which we probably won't need to do some networking mumbo jumbo around it. And yeah, that will probably be very exciting when that comes out. Cool.
Yeah,
all right.
sure.
And I wonder, Mayuri, do you have anything to show us so we can see this in action?
Yep. Actually, I do have a demo I could show you.
Oh,
yes,
fantastic.
please. Demos are always good. Just roll with it.
Just a second. Okay, let me get this going. It's all good, right? You can see the screen?
Yes,
Yeah.
it would be great if you could zoom in just a little bit, please.
So this is actually a recording.
Okay.
I'll walk
Okay.
through, and this is like maximized. It was actually a lot smaller. This is a lot
That's
better
fine.
now. All
I
right.
think it will do.
So, right. Shall we start? All good?
Yeah, please.
All good.
Okay, great. So here I have an Arc connected cluster, and currently I'm in a resource group, and this Meiji East US2 demo 2 is the Arc connected cluster. As I've already connected it in advance. This is an East US2 region. So what I'm going to first do for this cluster is install the extension. The way it's done is using case extension create command, az case extension create. This is a separate API you use when you're installing extensions on an Arc connected cluster. So you provide the parameters like extension type of Microsoft or Open Service Mesh, which version of Open Service Mesh you're going to install, along with a configuration settings file. Now, this configuration settings file is optional, but I am providing that now when I'm installing the cluster, because I need to set the permissive traffic policy mode to false. By default, it's true. I'm setting it to false explicitly because I want to show you exactly how you apply the SMI policies, which are the set of APIs you actually use when you enable the functionality, the features of Open Service Mesh. So I'm deploying it with these configuration settings. It takes a while to deploy, like 3 or 4 minutes. And while that's happening, I think, let's see. Right. So meanwhile, I'll enable GitOps on the same cluster, because the way I'm going to apply all these SMI policies and all of the configuration on the cluster would be through GitOps. So I'm just providing a configuration name, the instance name of the GitOps config I want to get deployed on the cluster. And the repo that I'm using is just a demo repo I created for this particular demo. This is a public repository that doesn't contain anything as of now except for the README file. So I'm connecting to its main branch. There are 2 branches in this repo. I'm connecting to its main branch and just providing that URL over there, along with the parameter that actually specifically calls out for the main branch. So once you, then the other branch, by the way, is OSM demo one, as you can see. So once I create this configuration, it takes about a couple of minutes, maybe a bit more, to actually create this GitOps, this configuration on the cluster. It flows down and eventually creates a flux operator on the cluster. So then it watches for any changes in the manifest that you have in the main branch of the repo. So with Helm LS, as you can see, I do have OSM deployed on the cluster. By this time, that's deployed. And over 5 minutes or so, if you check, you do have now OSM config as well, which is the two new operators that we added for GitOps. So there you can see the state is installed and the parameters are, it's reading only. So the default state that I'm enabling for configuration is read only for that repo. So what I've done locally is that I have, connected my local branch. I've created a clone of this repo, and then I'm connecting to the OSM demo one branch. And now in that locally, what I'm doing is I'm pasting the YAML files of my deployment there. And what those YAML files really contain is a manifest of the namespace, which already has labels of OSM. So that whenever this namespace is deployed, I'm just going to go back a little bit. So that whenever this namespace is deployed, I don't have to manually onboard the namespaces onto the mesh, because that's the first thing that you do after deploying a service mesh. You basically, in case of open service mesh, you use the OSM CLI otherwise. And what you do with it is that you say OSM namespace add, and you add a bunch of namespaces, which basically helps the OSM controller pod to track all those namespaces. And that's how the sidecars, which is Envoy proxy in our case, is injected into all of those application pods that then come up in those namespaces. So rather than doing that manually, I'm doing all of this through GitOps. And so I've already enabled the labels of monitoring and sidecar injection while creating the namespace. And then I have a deployment of book buyer and a service account of book buyer in this particular case. So as such, there are about 5 YAML files, 5 different services, which I'm going to deploy. So over there, I'm just going to stage the changes and just going to move forward a bit. I'm going to push it there. So once, yep. Gone in now. Okay, so there now you can see I have the changes over here. I'm just gonna create a pull request, and at this point of time, once you have a pull request, right, it becomes very easy for anybody to see what changes are really going in the cluster, be it OSM related, be it outside. So the reason why I wanted to show you GitOps way of deploying policies is because the same thing can be extended to a lot of clusters and not just one, right? A lot many times the person or the team who's managing the clusters at an infrastructure level, that is very different from the team who's deploying code on the same clusters, right? So this helps bridge that gap between the application team and the infrastructure team. So when you have these changes, somebody can then go ahead and then review those changes and see, okay, these are the ones that these are the policies, or these are the applications I'm going to deploy.
And maybe if I ask you a little question here, because I think GitOps is a fantastic way to deploy these things, and thank you for showing it. But for those listeners or watchers that are not familiar with GitOps, could you maybe quickly describe what GitOps is and how it integrates with Arc?
Sure. I can show you at a high level, tell you at a high level. So what GitOps in this case, for example, was doing for me is that I have connected my Azure Arc cluster to a particular kind of binded that together, right? So I have a repository. It could be a private or a public repository. And then I have connected my Arc cluster to it. So basically, there is a Flux operator that gets deployed on the Arc connected cluster. It will watch for any configuration changes. So eventually, when you create when you go to the Azure portal and when you create that GitOps configuration, it will at the backend it will create an Azure Resource Manager configuration for the customer. So so the Flux operator will watch for any changes in that ARM resource first. Now, whenever there is a configuration, that's when it will bind the GitHub repo which is mentioned in that configuration to the cluster. And then going forward, the Flux operator will basically simply watch the repo for any changes in the manifest, and going, this is only going forward. So from this point onwards, whenever you've signed up for the changes for this GitOps, from this moment onwards, it will watch for any future changes in the YAML files or whatever files that you deploy, and that basically becomes a desired state. And whenever there is a change, it will simply trickle down to the cluster and will get deployed. The same files will be deployed on the cluster. It takes a while. It's almost instantaneous, but we say wait for about 5 minutes or so at max for the changes to trickle down.
So does that mean no more needing to do Helm install or kubectl apply? You just commit to a Git repo, and after a couple of minutes, it shows up in your cluster. Is that what you're saying?
Exactly.
Oh, that's
And
nice.
this helps you, and this helps you in a case where you don't have direct line of sight with the cluster, right? So the cluster is, let's say, somewhere remote. Somebody else deployed it, and you are now in charge of, handling the code that gets deployed on it. So you don't really need access to the cluster directly. All you need is access to that GitHub repo. As long as you're maintaining it, you're maintaining the cluster.
Pretty cool.
So in this case, I'm going to continue with the demo. In this case, when I deploy these applications in a while, in a couple of minutes, I can see the 4-5 applications deployed over here. And I'm going to go back a little. And if you notice closely, the pods which are run, the containers which are running for each of these application pods are 2. The reason, because the first is the application container, and the second one is the Envoy proxy. So because of the labels and annotations which I added, and because of course OSM control plane is already up and functioning in this cluster, the sidecar is injected, and now both the containers are running within each of these application pods. All right. Next, we're going to show how, so this is the OSM upstream demo, and this is exactly what I'm using for this particular demo. I've done some basic port forwarding, and I'm going to show if at all there is any traffic that's flowing between these services. Right now, there is none, because we explicitly removed change the permissive traffic policy mode. So now I'm going to apply an SMI policy, which will unlock that channel. So it will create a service account. It will create this traffic target kind Kubernetes object, which is specifically used for applying SMI policies. And then it will give access to both the services, book buyer and book thief, to access the service of bookstore. And the way I did it is basically simply just pasted this file in my local. I'm going to commit the changes, push it to the fork of the repo, and then I'm going to merge it. I'm just going to fast forward that. Right, so this is the traffic target. I'm going to pause it a little because I think the font there back there was very small. So this was a traffic target object type which I'm creating for the SMI from the SMI policy. Here, I think we know that what all exactly goes in that. I know that we also talked to Philip Gibson in one of the sessions and as part of the series. So here, for the destination bookstore, we are giving access to book buyer and book thief sources. So we basically create two type of Kubernetes objects over here. One is traffic target, and the other is HTTP route group to enable this access. And so once we do that, and we've merged it, it's almost I think a couple of minutes or so, and now you can see that the traffic is flowing. So book buyer is able to access bookstore v1, and book thief is also able to access bookstore v1. So the app is designed such that you see the traffic moving, it auto refreshes. All right, so the next thing, and this is pretty interesting. Now, this is something which is unique, and you get it only when you deploy this open service mesh as a managed offering. We are going to do many such integrations in future, but today when you deploy an open service mesh, you have the luxury of also deploying Azure Monitor on the same cluster and then connect the two things together. So instead of using your own add-ons of Prometheus or Grafana, which people typically use in the service mesh world, instead of doing that, you can simply just deploy Azure Monitor extension, just change a config map, and see similar metrics on the Azure Monitor blades as well. And I'll show you exactly what all things you can do. So first, I'm going to deploy an Azure Monitor extension. For that, I'm just looking for the resource ID of Analytics Workspace, which I specifically created for this. So once I have that, the way to install the extension is the same as I install as installing OSM extension, for example. Use AZ8 extension create command, and you provide cluster type, and extension type in this case would be Microsoft.Azure Monitor containers. And within the configuration settings parameter, we are going to provide log analytics workspace resource ID, which we just copied from the portal. So once we deploy this, just move forward. Right. Once we deploy this, we're going to go to our Azure Arc cluster and see what extensions we have. So we have a dedicated extensions blade. This is where we can see what all extensions we already have. So we have OSM, which we deployed earlier, and now we have Azure Monitor containers as well. Now, how do we bind these things together? How do we connect it? That's an interesting part. So
yeah, that's what we are waiting for.
Yeah. So, all right. So there are two things. So one, I mentioned that there is a config map. That's how you bind it. So I'm applying a config map file, which is provided by the Azure Monitor team. And basically, what you do is, I'm going to pause here a little. I know that the text may be too small. So here, this is a simple config map file, a config map Kubernetes object, and within this you have a parameter called monitor underscore namespaces. Now within this parameter, you add all of the namespaces which you want to be tracked by Azure Monitor. So there are two parts to it. One, you need the metrics to be enabled by the Open Service Mesh controller. So right now, there are the endpoints, right? The Prometheus endpoints are not exposed as such by Service Mesh by default. So you need to enable the metrics, or generating the metrics is something that you need to enable. And then second thing is, you need to let the Azure Monitor know that now you need to watch for these namespaces and any metrics generated as part of these namespaces, whatever be the application pods running between them. So we deploy this config map. And the way I'm going to deploy it is again through GitOps. Let me see if I covered that here. Yeah, and while that's done, I'm enabling the metrics for these particular namespaces. Now, this is there are two ways to do it. One, you can do it through OSM CLI, which is what I did in this particular case, or you could have simply gone into the manifest file of the namespaces, right? And then added additional labels or the annotations, the same thing that I did previously when I wanted to import certain namespaces to the mesh. So two ways to do it. This time around, since I had direct access to the cluster, I did OSM CLI. So we enable the metrics and then go back and then merge the monitor config. And then once you're done, so the way to access the dashboard, it's currently in a preview. We won't be able to access it directly through our portal if we go in and try to do that. There is a specific link provided in the documentation of our Enable Kubernetes cluster. We need to open that link. It's kind of has that feature flag. Once you go there, then you go to Insights under Monitoring section. And within that, you see 4 or 5 categories. One of those categories is networking. Now, within that networking, we have added this workbook of OSM monitoring. You click that OSM monitoring, and whatever workspace this particular Arc cluster is tied to, it will show up the data from that workspace. And I'm going to pause it on the previous screen a bit. So by default, it will show all of the services which it's tracking. Some of the high-level metrics of it, like what are the HTTP requests in total that we have seen in the last 1 hour, the time range selected is last 1 hour. What are the output bytes sent, output bytes received. And then once you click on a particular service, which is a source service, you will see what all destination services are connected to this particular service. So in this case, there's only one, which is a bookstore destination service. And you see that for this particular connection, book buyer to bookstore, what are the total number of requests sent, what is the error rate for the same connection, and what's the latency. And when you further go down and click on this particular destination service, that's where you start seeing the service to service connection related metrics. These are the standard golden metrics whenever you want to watch for service performance, like latency, success rate, P90, P95, and you basically see that over time series. So something that customers can monitor when they have both the extensions running.
And for these dashboards, do these dashboards come pre-built with the service, or do I as a user have to configure those before I get the dashboards itself, or does it come straight when I enable the integration?
This is out of the box, so you don't need to create these dashboards. However, but you do have, there is a way, and you can potentially use that enhanced capability when you have more than one cluster connected this way. So let's say you had 3 or 4 are connected clusters and you enabled monitoring and OSM on all of those. Now you want to see all of those in one place. So instead of going to each and every Arc cluster and then going to Insights, then opening the Reports tab, what you can directly do is you can pick the views that are interesting for you and create a dashboard for yourself. This is something that Azure Monitor anyway provides, right? So you can pin those views, create a dashboard of your own, then eventually you can, see everything in one place. But otherwise, if it's just one cluster, this is pretty much out of the box.
Cool, thank you.
Cool, nice.
This is all I had for the demo. I think specifics around what service mesh can do, what it can't, I think we've probably already covered it. So, yeah.
So, are we going to see more of an integration for Arc also for an observability part? Because I discussed that already a little bit with Phil in the past, and I think that was on the roadmap, but will this also be applying to the Arc enabled OSM?
Right. So on the observability side, there are a few gaps, or I would say few things that we kind of need to add to our capabilities list. So one is distributed tracing, for example. We don't have that today. Although we do have that in the upstream project, so somebody can go ahead and deploy Jaeger and enable distributed tracing, right? That is something they can do even outside of Microsoft. And even if they have this, they can go ahead and deploy Jaeger. But something which is managed, right? All of that I think would be enabled through Azure Monitor. So there is an application insights is one of the things that Azure Monitor offers. So within application insight, distributed tracing is one of the things that it enables. So we may be looking at that to enable two things for us. One is mesh topology, wherein you can see all of the clusters, like you have in Kiali. A lot of people are familiar with it.
That's what I'm aiming
Right.
for.
Yeah, and a lot of people do inquire about it, and it's a fair ask. So you see service to service and version to version connections, where the traffic is going, what percentage of traffic is flowing, and then over those, connections, you see a lot many more metrics. It's very rich. So we do aim to get there with the integration of App Insights along with this monitor. It will use the same channel for pulling the metrics, but will of course be able to build that graph. That's one, and the other thing is distributed tracing.
Okay,
Cool.
That sounds really interesting. Thank you for joining us today.
Thank you. Glad to be here.
It's an unsung hero, but it's an unknown unsung hero even, because we're still moving towards a delivery of the product. When can we probably see this, or can we try it ourselves? Can we already try it ourselves? Is it available for us?
You can.
Okay.
Yeah. This is in public preview. So everything that you see over here, you do not need any whitelisting to get started. Just follow the documentation. This is, you simply type Azure Arc enabled open service mesh on Google, and I think you'll find that documentation.
Pretty cool. Well, thank you a lot for this nice introduction to OSM Arc enabled. This is really, really nice to see. This is a nice evolution. And I think a lot of people, a lot of developers, and a lot of Kubernetes fans, and a lot of people who are designing microservices and all these things will benefit from this somehow. So that's really nice.
For sure. And I think this monitor is just, one place for us to start. I mean, there are so many Azure services we would want to integrate with in future. So I don't want to call them out, the roadmap, because don't want to set any expectations right now. But yes, we'll definitely be in the future. We'll definitely be integrating with many more, so that you can utilize the existing power of Azure when you have OSM also.
Take a look at Event Grid too. That's a tip.
Yeah. All right.
And I'd say once you have Event Grid enabled on Azure Arc enabled Kubernetes, we will gladly have you on again.
Yeah.
All right.
Keep it coming.
Super.
All right.
I think with that, thank you for coming on, because you shared a great demo and some really great information. For everybody who tuned in, thanks for sticking with us, and I guess we will see you again in 2 weeks.
Yep, I think so. All right, bye everybody.
Yeah.
See you again in 2 weeks, and have a pleasant continuation of the summer. Bye-bye.